A one-sided limit is the y value a function approaches as you approach a given x value from either the left or right side. If you look at the first example here, the limit of f as x approaches 3 from the left side is -1. So you see x is equal to 3 is right here. As you approach it from the left, so like the left approach, which on the graph is right here, you see you're approaching a y value of -1. So the way you'd write it is limit as x approaches 3 from the left. You write that negative sign up there. 3 from the left is equal to -1. The limit of f as x approaches 3 from the right side is 2. So 3 from the right would be approaching 3 from the right, but on the graph, it's right up here. You see you're approaching a y value of 2. As x approaches 3 from the right, you're approaching a y value of 2. So for 3 from the right, you do 3 and like a plus in the exponent is 2. So you can see here how the left-hand limit and the right-hand limit are different. So if these are different, if the left and the right-hand limit are different, this is what we call the general limit. The general limit only exists if the left-hand limit is equal to the right-hand limit. But -1 is not equal to 2, so therefore this limit does not exist. So example 2. Limit as x approaches -2 from the left. So -2 is right here. From the left would be approaching right here. You see that's a y value of 1. B. Limit as x approaches -2 from the right. So -2 is right here from the right. So you see the graph functions approaching right here, which is also a y value of -2. C. Limit as x approaches -2. It doesn't say the left or the right, so it's just the general limit. Again, the general limit only exists if the left and the right are equal the same. But you see here the left-hand limit's 1, the right-hand limit's -2, therefore this does not exist. Part D, limit as x approaches 1 of f of x. So when we look at this limit, we have to ensure that the left and the right-hand limits are approaching the same thing. See x's 1's right here, and you can see here we are approaching the same value from the left and right, a y value of 1. So the general limit as x approaches 1 is 1. Limit as x approaches 0. 0 is just this y-axis right here. You can see as we approach from the left and the right right here, we're approaching a y value of -2. Limit as x approaches 3 from the left. So 3 is right here. From the left, you're approaching a y value of 1, 2, 3, 4, 5 right here. In this case, you can see the left-hand limit, the right-hand limit both approach the same value, but they're just asking for the left-hand limit, which is 5. But if it was the right-hand limit, it'd be a 5 as well. And if they ask for the general limit as x approaches 3, it would still be a value of 5. So limit as x approaches a -1. You see -1 is right here. You see the left and the right, they're both approaching this value, y value of -3. F of 1. You see at x is equal to 1 right here, they're not asking for the limit, they're asking at 1. That's where the black dot is, right here, at a y value of -2. F of -2, again, at -2, where's the black dot? It's up here, a y value of 1. All right. Example 3. I'd say this is definitely one that students struggle with a lot because it involves a lot of like trial and error. So you want to So with example 1 and 2, or example 2, we're given a graph and we're asked to find certain limits, or what a function is with a certain input. We're going backwards now. We're given some conditions and we have to create our graph ourselves. So part A, so to do these, you want to go through the conditions one at a time. So g of 3 is equal to -1. So at x is equal to 3, y is equal to -1. So there has to be a point right there. We can check that off. Limit as x approaches 3 of g of x is 4. So limit as x approaches 3 of g of x is equal to 4. This would actually have to be a whole because the function's already at x equal to 3. They tell us the function has an output of -1. We can't have two black dots here because you can't have two different outputs for one input. If there's already a black dot here, this cannot be a black dot. It has to be an open hole like this. So tricky part here is we don't know if the graph would look like this, like this. There isn't one right answer. There's a lot of different options. So for now, I'm gonna just pick something like this. Check that condition. Limit as x approaches -2 from the right is equal to 1. -2 from the right is equal to 1. Again, I don't know if it's a open or a closed hole. Again, there's many different options, but I'm going to just keep it like this. So from the right, as x approaches -2 from the right, we're approaching 1. Cool. G is increasing from -2 for x values between -2 and 3. So from -2 to 3, this graph should always be increasing. So we can just connect these right here. Last one here. Limit as x approaches -2 from the left is greater than the limit as x approaches -2 from the right. So we can do like an open or a closed, so it don't matter right here. And that's a limit right there. And I'm gonna just draw these arrows just to show that the graph is going and going. So in this case, if you check all these conditions, it satisfies all of them. Every time you do these though, you're gonna have to erase. Sometimes you'll do the first couple conditions correct, and then you'll do the third one, and you have to change some other parts of your graph. This requires a lot of trial and error. Every time you make a graph and make changes, be sure you go through all the previous conditions and make sure those are still met. If you have questions, please ask your teacher for assistance and to check your work if you're unsure, because these problems are typically the most confusing, and there is one on the master check.